Thanks, Agent Terry. First, we will introduce Trendland, a collection of scientific papers that use the derivative sign to calculate functions' local trends in engineering, science, and math. As a quick refresher, the sign function maps any number to -1, 0, or +1, depending on whether it's negative, 0, or positive. Therefore, the sign of the derivative is a simple way to inquire about the function's trend. Like in real life, trends in AI are everywhere you look. They are increasingly becoming the go-to tool for many applications, from deep, adversarial, and meta machine learning to various computer vision tasks. This is because functions' trends of change often provide more valuable insights than the rates of change of those functions, and the rates are overlooked on purpose. So join me on this journey as we dive deeper into the world of AI trends. For example, an emerging family of optimization algorithms is commonly called the sign gradient descent method. These approaches originated with the R-prop algorithm in the 90s. Recently, many cutting-edge optimization algorithms, such as the sign gradient descent and sign stochastic gradient descent, rely on the function's trends rather than rates in their update calculation. Why are trends all the rage? One of the most significant benefits is their ability to handle noisy data more effectively. Trends are also more resistant to fluctuations in functions, particularly near extrema points. They are also computationally lighter than rates, which saves energy and allows a more efficient runtime performance. Trends also reduce overfitting when used as features. They serve to improve the invariance to minor details that might affect models and applications, for example in edge detection in computer vision. They can address the vanishing and exploding gradient better because trends are a way to discretize and bound gradients, and in some cases, where it's impossible to calculate rates, it is still possible to calculate trends, which makes their calculation a viable fallback. To further explore trends applications, check out this blog post. It surveys over 1,000 trend applications across various fields of study, focusing on AI. In Trendland applications, trends are often calculated as the sign of the derivative. Should it be like that? Since the sign function is multiplicative, dividing by h or 2h when approximating the derivative in discrete domains doesn't add anything to the calculation of the sign. Essentially, we'd get the same result from the sign function whether we compute the division or not. It's like dividing a pizza into equal slices only to glue them back together and serve it as a whole. This division round trip amounts to the following problems: compute time, potential overflow since h is tiny, gradient explosion, and redundancy, which might amount to a lack of clarity. It's worth noting that some applications from Trendland spare this division in discrete domains. The question is whether we should also pay more attention to this redundancy in continuous ones. In the words of one of the greatest mathematicians,
"Theory attracts practice, as the magnet attracts iron."
So when practical applications accumulate, it's time to reevaluate the underlying theory and existing concepts. That's precisely what we'll do with local trends.
Up next, we're diving into a fresh approach to calculus that underpins the practice we just explored. Curious about this new twist? Stick with us and let's uncover it together.